Well, today we're going to tackle 2011, question 4, part B. Now you can picture the poor students who sat their leaving cert this year and looked at this question and thought, oh my good lord. It is one of the more complex looking questions with many more moving parts than we usually see. But the important thing to remember is, if you have that many bits and pieces going on, it's probably a straightforward question. It's the questions that look elegantly simple, where there might be an interesting little twist in it that we need to think about. So they're not going to give you both. It's going to be one or the other. It's kind of a balance between them. So if we look at this question, if we read through the text, it basically tells us everything we see in the diagram. Okay, we don't need to worry about the top pulley. The strings are all light. They're all inextensible. And we want the tension in each string. There's, of course, 3 strings, 3 tensions. So let's lay this out. Now, normally I draw these guys out separately, but since it's such a complex diagram, just to minimize the chance of a mistake, I'm going to draw one big diagram here. So we'll just begin to lay this out. There's our big one. And we come down here. And our next pulley. And this guy here. Okay, don't worry, the sizes aren't perfect. It's not an art competition. We come down here. And there's our first mass. Second mass. Bring this guy down a bit small, a bit lower, just so we don't need to worry about that. All right, so there's all our bits and pieces. Now, this one is fixed, don't need to worry about it. That's 2 kilograms, that's 5, 1, 3, 4, and 6. Okay, so next step, we're going to work out all the forces on these objects. So we just go through them one by one. We'll call this big string here, get our tensions in there. So that is T1, which of course is pulling up in both of these guys. T1. Then we're going to call this one T2, so our second string. T2 is going up that way and going up this way. And of course it's pulling down on this object here. T2. Okay. And then this is T3. This is why we want a nice big diagram to fit all these little bits and pieces in. And there we go. There's T3 coming down here. Okay, next thing is our masses. So of course we have 1G or G going down there. 3G, 4G, 6G, and this is 2 and 5. So at least they're being nice to us by, only having one of each. So we can talk about the 2 kilogram mass and so on. And that's 5G there. Okay, now, the bit that makes this question tricky is accelerations, because we've got a few different bits and pieces going on. So what we'll do is, I'm going to mark out the accelerations in red. So first of all, this 2 is going to be going up and this 5 is going to be going down. So we have an acceleration going around this way, and we're going to call that A. All right. Now let's look at this one. Well, again, it's going to go around this way. So we have an acceleration that's going to be B. And the 4 is going to be pulled down by the 6. So that acceleration is C. So those are our 3 different accelerations. You can see straight away we have a huge amount of variables here. We've got A, B, C, T1, T2, T3, and we're going to have to reduce that down. So a lot of simultaneous equations in our future. Well, let's move over here and let's do our F equals ma. I'll stay in black just to be consistent. F equals ma. Well, we'll work for our masses. I'm going to do them in pairs because it's a bit easier to think about. So we'll deal with the 1 and the 3 kilos first. All right, so there is our 1 kilo mass, and on this guy it's going to be going up. So T2 minus G equals, now how is it going to be going up? Well, it's going to be going up with acceleration B on this string, and it's going to be going up with acceleration here, so it's A plus B. All right, the 3 kilogram mass is going to be going down this way, so 3G minus T2, and that equals, of course, 3 times, and this is going to be going down with B, but up with A. So it's going to be B minus A. All right. Okay, let's move along. Next one, we'll do 4 and 6. So 4 is going up. It's going to go up and around this way. So T3 minus 4G equals 4. And it's going to be going up with C and down with A. So C minus A. And once you get these accelerations right, the rest is just going to be banging on through all these equations. 6, so we'll say 6 comes down this way. 6G minus T3. And that is going to be going down 6 factor of C plus A. Because going down with C and going down with A. Okay, and we'll do 2 and 5 next. So there's 2. Give a circle because it's a pulley. So 2 is going to be going around this way. So T1 minus 2T2, 2 of these guys, minus 2G equals 2A. And 5, well, it's going to be going down this way. So we have 5G plus 2T3 minus T1, that is 5A. Okay, there's all of our equations here. Now we need to figure out kind of which way do we want to go. So we're looking for all the different tensions. So what we're going to try and do is lose the B and lose C. Okay, we just need to start knocking out some of these variables that we're not interested in. So we'll hang on to A. We just need to hang on to one of them. But A is consistent across them all, so it looks like the most useful one, acceleration to keep. So in this case, we want to lose B. So what we're going to do is we are going to multiply this one. So we'll get a 3B here and a B there. So this one is going to be by minus 3. Okay, and that's just the way it is. So we will end up with 3T2 minus 3T2 plus 3G equals minus 3A minus 3B. This one is as it is, so 3G minus T2 equals 3B minus 3A. So you can see here that the B is going to cancel out, and we'll be left with one of them together. We have minus 4T2 plus 6G equals minus 6A. All right, that's one bit of it there. These guys here, we want to lose C. So we'll just squeeze this in here, lose C. Sorry, it's getting a little bit crowded here. I am going to have a 4C there and a 6C there, so my common factor is going to be 12. So this one is going to be by minus 3, and that one is going to be by 2. And we'll end up with the way we can cancel them out. So minus 3T3 plus 12G equals minus 12C. Minus 4 by minus 3 is plus 12A. All right, next one here, a little bit easier. 12G minus 2T3 equals 12C plus 12A. Combining them together, and we are going to get 24G minus 5T3 equals, goodbye, 24A. Okay, so now what do we do here though? Because like, what are we going to knock out and get rid of and so on? Well, if we have a little look at this, I've got T2s and A's, T3s and A's. I don't have any T1s. So let's lose T1. Okay, plus T1 minus T1, this goes straight across, and we can actually kind of do it here. We'll just stick it in here for neatness. So these guys go, we end up with 3G minus 2T2 plus 2T3 equals 7A. Okay, so now we have these three equations here. Well, there's one of them. There's our next one, and there's our last one. So we've started with 6 unknowns, and we're now down to 1, 2, 3 unknowns. Getting a whole lot better, but we've got to go a little bit further. So what are we going to do next in this one? Well, I think what we're going to do is we want to get to our acceleration, because once we can put a value in our acceleration, everything else will fall out. All right. If I knew what A was, I know what T2 is, I know what T3 is, and then I can solve this one. So we are going to sub in A. So what we'll do is let's give these a little bit of a letter. We'll call this one X, call that one Y, and Z, just so you know what I'm talking about, because I'm going to need to bring stuff down around here. So for X, what I can say is that I want to get this in terms of A. So T2 equals something in terms of A. So I end up with bringing T2 across here, A across here. I end up with 4T2 equals 6G plus 6A. So T2 equals 6G plus 6A all over 4. All right. For Y, again, we'll bring these guys across. So I end up with 5T3. Bring that one over there, this one over here, equals 24G minus 24A. So T3 equals 24G minus 24A all over 5. Okay, so now I have these equations which are going to go into this one. We're running a little bit out of room, so I'm just going to switch to a new sheet. We'll bring that one back as we need it. So this course, 2011, question 4, part B, big beast. So what I want to do is take this equation here, Z. So I'll just copy it down here again. That's 3G minus 2T2 plus 2T3 equals 7A. I am going to sub in the values for T2 and T3 here. And then we've just got an equation for A, and we're going to solve for A. Okay, so that is going to get a little bit ugly. 3G minus 2 times 6G plus 6A plus 1 over 4 plus 2, subbing in T3, 24G minus 24A all over 5, and that equals 7A. Okay, let's multiply it all out and see what comes out of this. 3G minus, okay, I'm just going to keep this simple, 12G over 4 for the moment, minus 12A over 4. Again, a little kid, I know that's going to be 3, but kiss of death is we're doing 2 steps at once, we'll make a small slip on it, plus 48G over 5 minus 48G over 5 equals 7A. Right. Bang out these fractions here. 3G minus 3G, well, that's nice, isn't it? Minus 3A plus, well, we'll leave these the way they are. Little slip there, whoopsie daisies. 48G over 5 minus 48A over 5 equals 7A. So those two guys go. That's grand. Now we're just down to these 3 terms. And it's a whole equation. The only variable is A. Remember, G is a constant. So a little bit of rearranging. I'm going to get a value for A. So what I'll do is I'll bring the A's over this side here. So I end up with 48G over 5 equals 7A plus 3A plus 48 over 5A. Slightly annoying. That of course equals 10A plus 48 over 5A. And we'll just bring everything over 5 because I'm going to multiply both sides by 5. So what we'll do is we'll just multiply them all by 5 now. 48G equals 50A plus 48A. So A is going to equal 48 over 98G. Okay, we want to get an actual number on that one. So that is time for a calculator. So we have 48 by 9.8 divided by 98. You can really do that in your head actually. It was of course 4.8. So 4.8 meters per second. Now that I have A, I can go back and begin to substitute everything else out. Alright, so tensions. Well, T2, there it is in terms of A. So T2 equals 6 by 9.8, which is G of course, plus 6 by 4.8 all over 4. Okay, we'll do that on our calculator. 6 by 9.8 plus 4.8. 21.9. Okay, so T2 is 21.9 newtons. T3, there's a little value here, okay, equals 24 by 9.8 minus 24 by 4.8 all over 5. You actually might be able to do this in your head because you can see that that's going to be 24 factor of 9.8 minus 4.8, which is 24 by 5 divided by 5, which is 24 newtons. Okay, stick in your calculator if you're not sure about that, but it comes out quite nicely otherwise. Now for T1. So T1, we're going to go back to our little equation here. Where is our, okay? We actually just going to use either of this equation or this equation. So I may as well just take this one here. So the equation for the two kilogram pulley, sub T2 in, sub in A, and off I go. So that is T1 equals 2 by A, which was 4.8. Okay, and all I'm doing here is bringing the other values across. So I'm going to bring the minus 2T2 across and the minus 2G across. So that becomes plus 2 T2, which I just know is 21.9, plus 2G, 9.8. Put all of that into the equation. Okay, so that is 2 by, again, I'm just going to add all these together in the brackets, 4.8 plus 21.9 plus 9.8, 73. And those are my 3 tensions for this lovely big complicated beast of a question, which was actually just a nice bit of algebra practice in the end.